This is the review for your Unit 4 test study guide. The first topic we're going to talk about is complex numbers. And just remember, anytime you need to pause the video, you can. And if you have any more questions, you can still ask me. Like I said, the first topic is complex numbers. So for problem number 1, I have the square root of negative 324. When I'm solving this, I have to split it up into two things, because I have to have the square root of negative 1 and the square root of 324. Because I can't take the square root of a negative number and just get a number. If you remember, the square root of negative 1 equals I. The second part of this problem, the square root of 324, you have to see if it's a perfect square or not. Well, 324 is a perfect square, and the square root of 324 is 18. Once you take the square root of a number, the square root goes away. Do not keep it. So that your answer to this problem is going to be 18I. Problem number 2. Leave the 2 alone. Okay, let's just focus on the square root of negative 147. Take the negative out. The square root of negative 1 times the square root of 147. 147 is not a perfect square. But to find a perfect square that will go into 147 evenly, you just start dividing by the perfect squares. The biggest perfect square that will go into 147 is 49. So I'm going to split it up into the square root of 49 and the square root of 3. Because 49 times 3 is 147. Well, I'm going to leave 2. Leave 2 there. The square root of negative 1 is I. The square root of 49 is 7. And the square root of 3 is just 3. Now I have to multiply everything in front of the square root. So that 2 times 7 is 14I, because I has to stay with the square root of 3. That is my answer. Problem 3. If you look at problem 3, there is a difference between 3 and number 5. The difference is that number 3 has a plus sign in the middle, while number 5 doesn't have anything. Number 3 we are adding together, while number 5 we are multiplying. So when I'm just adding them together, if it's a plus sign, you distribute the plus sign, which doesn't change anything. So it's going to be negative 4 plus 7I minus 3 minus 8I. Combine like terms. Well, my real number goes first, so let's do those first. Negative 4 minus 3 gives me negative 7. 7I minus 8I gives me negative I or negative 1I. It doesn't matter which way you want to write it because it means the same thing. Number 4. This time, instead of having a plus sign in the middle, we have a negative sign. So I have to distribute the negative. So I'm going to leave the first numbers the same, 21 plus 9I, and distribute the negative. So a negative 1 times a positive 13 gives me a negative 13. A negative 1 times a negative 2I gives me a positive 2I. Combine like terms. 21 minus 13 is 8. And 9I plus 2I gives me positive 11I. So that is my answer. for this one and this one. Number 5. Like I said earlier, this is where you have to multiply or distribute, full method, whichever one you want to call it. So the first thing I have to do is 1 times 4, which gives me 4. And then 1 times negative 2i, which gives me negative 2i. Then I have to do the positive 5i times 4, which gives me positive 20i. And then a 5i times negative 2i, which gives me negative 10i squared. From here, I have to combine like terms. My like terms being negative 2i plus 20i. So I'm going to drop down the 4, combine the 2 in the middle, which gives me positive 18i, and drop down the negative 10i squared. Now, if you remember your I rules, I squared equals negative 1. So now I'm going to substitute negative 1 in for I squared, so that I get negative 10 times negative 1, which is really a positive 10. So now I can combine it one more time. 10 plus 14 gives me, 10 plus 4 gives me 14 plus 18i. Number 6, you're going to do the same thing as number 5. If you don't like the way it's written, you can rewrite it as 7 minus I times 7 minus I. Now use the full method. 7 times 7 is 49. 7 times negative I is negative 7i. Negative I times 7 is negative 7i. And negative I times negative I is positive I squared. Combine like terms. 49 minus 14i plus I squared. Substitute negative 1 in for I squared so that you get plus negative 1. Positive times a negative becomes a negative. And combine like terms one last time. 49 minus 1 is 48 minus 14i. Number 7. Number 7 is different than number 8 because here you only have one term at the bottom, while on number 8 you have 2. You have the 4 and then the negative 3. That's how those two are different. So for number 7, if I just have one number on the bottom, you multiply top and bottom by I. Because we don't want i's on the bottom. We have to get rid of them. So when I do that, I say, okay, well, 8 times I is 8i. Negative 12i times I is negative 12i squared. Well, like we did in the last two problems, I squared equals negative 1. So I'm going to substitute it in so that I get 8i on top and a positive 12 on bottom. This is not your final answer. It can simplify. If you do not simplify, you will not get full credit. The biggest number that will go into both 8 and 12 is 4. So 8 divided by 8 divided by 4 is 2i, and 12 divided by 4 is going to be 3. So this will be your final answer. Number 8. because number 8 has the two terms on bottom like previously discussed, this time you'll have to multiply by the conjugate. The conjugate is just going to be the opposite sign where the I is. So here I have 4 minus 3i, so the conjugate is going to be 4 plus 3i. The whole point of the conjugate is to cancel out the i's. That's the reason why we have to multiply by the conjugate. And because I multiply the bottom by the conjugate, I also have to multiply the top. So that I now use the full method for both. 3 times 4 is 12. 3 times 3 is 9. But there's an I on the end, so don't forget your I. Negative 6i times 4 is negative 24i. And then negative 6i times 3i is negative 18i squared. So now we have to do the bottom. 4 times 4 is 16. 4 times positive 3i is plus 12i. Negative 3i times 4 is negative 12i. And negative 3 times positive 3 is negative 9i squared. From here, we need to combine our like terms. Our like terms for the top are here. So that I'm going to be left with 12 minus 9 minus 24 should give me, I believe, 15. Let me double check. Yep. Negative 15i minus 18i squared. If you want to go ahead and plug in negative 1 for I squared on this step, you can, but you don't have to. 16 for the bottom. These are my like terms. Well, positive 12i minus 12i is just going to cancel out, so I'm going to be left with minus 9i squared. Substitute negative 1 in for the I squared. And I forgot my I right here. That should be negative 15i. 12 minus 15i minus 18 times negative 1 over. So for the bottom, I'm still going to substitute negative 1 in for I squared. Therefore, I'm running out of room, so I'm just going to kind of mark that out, because you know that negative 18 times negative 1 is going to give me a positive 18, while down here, a negative 9 times a negative 1 is going to give me positive 9. So I'm going to have 12 plus 18, which is 30 minus 15i divided by 16 plus 9, which gives me 25. This will also simplify. A number that will go into both 30, 15, and 25 is 5. 30 divided by 5 is 6. 15 divided by 5 is negative 3i. And 25 divided by 5 is 5. So this is your final answer. Number 9 says to simplify and then name all the sets to which the value belongs. Remember, for number 9, I said all you have to do is take this number, 59, and divide by 4. When you do 59 and divide it by 4, you get 14 0.75. I could care less about the 14. I just want to know what this decimal place is. I want to list my I squares, I cube, I fourth, I. If you get 0.25, you use this. 0.50, you use I squared. And 0.75, you use I cubed. And if you get a whole number, so no decimal point, you use I to the fourth. Well, I equals I. I squared, -1. I third is -I. And I to the fourth is +1. So in this case, we got 0.75. So I'm going to use this. So my answer is going to be I to the 59th equals -I. That's the simplified part. The second part says the name all the sets to which this value belongs to. Well, all numbers are complex, whether they're real or imaginary. And because it includes an imaginary number or includes I, and just I, nothing else, it's also imaginary. It's a pure imaginary number. Number 10, simplify. I still have to use a full method. 9 times 9 is 81. 9 times -5 is -45i. 5 times 9 is +45i. And then 5 times -5 is -25i squared. Combine like terms. I'm going to get 81. -45i plus 45i will cancel out. So I'm going to be left with 81 minus 25i squared. Substitute in -1. 81 minus 25 times -1. 81 plus 25, because -25 times a -1 is +25. 81 plus 25 is going to give you 106. This is a simplified answer. So to list all the sets, well, it's a complex number. It does not have an I, so that means it's real. Because it's a whole number, it's going to be rational. Because it doesn't have any decimal places, it is going to be an integer. Because it's not negative, it's also a whole number. And because it's bigger than 0, it's going to be a natural number. Use the complex numbers to write an example of each of the properties. Remember, the associative property says that I can change the order in which I multiply and still get the same answer. So if I have 5 times 3i times 2, I would get the same answer as if I did 5 times 3i times 2. I suggest you also try to write an example on your own and not use mine. That way you can get some practice in it. Number 12 is the distributive property. So here, you are going to distribute a number within a set of parentheses. So if I use -7 times 3 minus 5i, the property says you're going to distribute, so -7 times 3 gives me negative 21. Negative 7 times negative 5 gives me positive 35i. Number 13, name the additive identity of negative 10 plus 4i. Okay? Additive means to add. And the identity part is what you have to do to get the same thing. So what do I have to add to negative 10 plus 4i to get the same thing? And the answer is 0. Now number 13 is I'm sorry, I have problems pronouncing this word. The multiplicative is multiplying, and the inverse is kind of tricky. If you're multiplying, you want to get back to 1. So get to 1. If you're adding, as a side note, I'm going to come down here. If adding, you want to get to 0. So if you are adding, you want to get to 0. Multiplying, you want to get to 1. So for 14, it's 7i. What do I have to add? I'm sorry, we're multiplying. Confusing myself. What do I have to multiply 7i to get to 1? Well, here, all you're going to do is multiply by the reciprocal. So for this problem, I'm going to multiply by 1 over 7i. Let's say, just as an example, let's also find the adding. What do I have to add to 7i to get to 0? This one, all you have to do is change the sign. So add a negative 7i. So that's an example of both multiplying and adding for inverse. So the last proper thing we're going to talk about for this topic is to name all the sets that are closed under subtraction. Well, the first one we have complex, we have imaginary, we have real, we have irrational and rational. I almost used the wrong letter. Then we have integers, whole numbers, natural numbers. Okay, these are all the sets that we could get as an answer. So if I have a complex number, 3 minus 2, and I subtract them, I'm going to get 1. 1's still a complex number, so that checks out. Irrational number, or imaginary number, 3i minus 2i, and I get I. Well, that's still imaginary, so that checks out. A real number, 2 pi minus pi. This covers real and irrational. I messed up the symbol here. That shouldn't be. Sorry, guys. That should be a little I, not a big I. Gives me pi. Still a real number, and it's still an irrational number, so that works out. A rational number could be 3/4 minus 1/4, and I get 1/2. Well, that's still rational. So that one checks out. Integers, Negative 3 minus 5 is negative 8. Well, yep, works out. Whole numbers. Zero is a whole number, and I subtract another whole number, 3, and I get negative 3. Negative 3 is not a whole number, so that one doesn't work. And natural numbers, so let's say I had 2, and I subtract 4. 2 and 4 are both a natural number. 2 minus 4 gives me negative 2. Negative 2 is not a natural number, so those two don't work. So my only answer is here. C little I R I Q Z. Okay. Topic 2, solving quadratics by graphing. When you are solving quadratics by graphing, remember the answer is where it crosses the x-axis. So to find my vertex, I'm going to use the formula of opposite of b divided by 2a, where a is here, b is here, c is here. The opposite of b. So instead of positive 10, it's going to be negative 10 divided by 2 times 1, because a is 1. Negative 10 divided by 2 gives me negative 5. Plug negative 5 back into my formula. Negative 5 squared plus 10 times negative 5 plus 24. It's going to give me 25 minus 50 plus 24. So it's going to be negative 25 plus 24, and I get negative 1. So this is my vertex. So I'm going to go put a point on my vertex. Okay? From here, if you want to create a chart, you can. I am running out of room, so I don't have a lot of space for my chart. So I'm going to put it over here, and then when I get to that problem, I'm going to erase it. So I'm going to put my vertex in the middle of my table. Negative 5, negative 1. One number, sorry, I'm going backwards. And then using your calculator, you're going to finish filling out the chart. If you plug in negative 6, you get 0. Plug in negative 4, you get 0. Plug in negative 7, you get 3. And negative 3, you get 3. If you don't get these answers, please let me know and I will come help. And for the last two, it's 8. Alright, so once you get your table set up, all you have to do now is plot your points. So I've already plotted my vertex, so I'm going to go to negative 6, 0, negative 4, 0, negative 3, 3, negative 7, 3, and negative 2, 8, and negative 8, 8, and graph. Remember what I said earlier, your solution to the problem is where it crosses the x-axis. For this set, your answer is going to be x equals negative 6, comma, negative 4. That is your answer. So for the next problem, number 17, I'm going to erase my table because it's kind of in my way, so I hope you got it down. I still have to use the same formula. Opposite of b divided by 2a. I'm still using the same formula. So here, my b is negative 6. So it's going to be positive 6 divided by 2 times negative 3, which is going to be 6 over negative 6, which equals negative 1. Plug it in. Negative 3 times negative 1 squared minus 6 times negative 1. Well, negative 1 squared is positive 1 times negative 3 gives me negative 3. Negative 6 times negative 1 gives me a positive 6. So that negative 3 plus 6 gives me 3. So 3 goes right there. Continue with writing another table on the side of your paper. XY. Negative 1, 3 goes in the middle. Negative 2, negative 3. I didn't leave myself enough room. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Plug them in. And once you plug them in, you should get negative 4, negative 24. Negative 3, negative 9. Negative 2, 0. Negative 1, 3. 0, 0. 1, negative 9. 2, negative 24. So once you graph or draw your table, you then can graph. So if I go to negative 4, 24, it's going to be somewhere way, way, way up here. So I don't have to graph it. So I do negative 3, negative 9, which is about here. Negative 2, 0. Negative 1, 3. 0, 0. 1, negative 9. And I still can't graph 2, negative 24. So it's going to look something like that. And that should look like a view. And I don't know why I said negative 24 is up here. It's really way down here somewhere. Alright, your solution is still where it crosses the x-axis. So here, it's going to be negative 2 and 0. That's your answer. Topic 13, solving by factoring. Remember, if the number in front of x squared is 1, then you just do 1 times 18, factors of 18. 1, 18, 2, 9, 3, 6. And that's it. Because it's a positive 18, all my signs are going to be the same. They take the sign of the middle number, so that means they're all going to be negative. Now ask yourself, which numbers will add to give me negative 11? Negative 9, negative 2. So it's going to be x minus 2 times x minus 9. That's just factoring. The solving part is where we say x minus 2 equals 0 and x minus 9 equals 0. Solve for x. Add 2 to both sides. X equals 2. Add 9 to both sides. X equals 9. So that my final answer is x equals 2, 9. That is my final answer. Number 19. Always check to make sure you don't have a greatest common factor. For this problem, you do have a greatest common factor, and that is 2. So I have to factor out a 2. So when I pull that 2 out, all I do is divide everything by 2. Well, 2 times divided by 2 is 1, so I'm going to have x squared. Negative 32 divided by 2 is going to give me negative 16x. And 128 divided by 2 is going to give me positive 64. So factors of 64, that will add to give me negative 16. 164, 2 and 32, 4 is 4 and 16, 8, and 8. There again, my last number is positive, and my middle number is negative, so they're all going to have opposite signs. Well, the factors I add to give me negative 16 are these two. So you're going to have 2 parentheses x minus 8 times x minus 8. Set them all equal to 0. 2 equals 0, x minus 8 equals 0, and x minus 8 equals 0. This does not matter. Add 8 to both sides. X equals 8. X equals 8. So my final answer is x equals 8. Number 20. There again, I still have a greatest common factor. My greatest common factor is going to be 2. So I'm going to factor out a 2. But it also has a variable in common, 2x. So when I pull out the 2x, I'm going to rewrite it over here. Divide everything by 2x. 8 divided by 2 is 4. X squared divided by x is x. 10 divided by 2 is 5. X divided by x is just 1. So it's going to be 2x times 4x plus 5. Set 2x equal to 0. 4x plus 5 equal to 0. Divide by 2. And you get x equals 0. Subtract 4. 4x equals negative 5. And divide both sides by 4. So that I get x equals negative 5 over 4. So my final answer for this is going to be x equals 0, negative 5 over 4. Okay, number 21. If you look, you do not have a greatest common factor here. Okay? So because I don't have a greatest common factor, now I start factoring by busting the b. To bust the b, I do 7 times negative 6. When you do 7 times negative 6, you're going to get negative 42. Factors of negative 42 are going to be 142, 2, 21, 3, and 14. 6 and 7. Okay, because this is a negative, my signs are going to be different, and the bigger number takes the sign of the middle number. So my bigger numbers are going to be negative. Factors of negative 42 that will add to give me negative 19. Your answer is 2 and negative 21. So remember, I'm going to write everything the same, except here, I'm going to write plus 2x minus 21x minus 6 equals 0. Group. Pull out the common factor. For the first set, it's going to be x. So it's going to give me 7x plus 2. For the second part, it's going to be a negative 3. Negative 21 divided by negative 3 gives me a positive 7x plus 2. We got these as the same. That's what we want. So rewrite it as 7x plus 2 times what's left, x minus 3 equals 0. Set them both equal to 0. 7x plus 2 equals 0. X minus 3 equals 0. Subtract 2. Add 3. So for this one, x is equal to 3. Divide by 7. And you get x equals negative 2 over 7. So that my final answer is x equals negative 2 over 7, comma 3. Okay. The next thing that we're going to talk about is completing the table. So they want us to go from standard to vertex to factored form. Well, if you remember, when we were converting to vertex form, we would write everything the same as x squared plus 16x plus 63, and we left this blank. What gets put in the blank is 16 divided by 2 equals 8. 8 squared is 64. So 64 gets put in the blank. What is out here, you multiply 1 times 64, which gives me positive 64, subtract it. So now I can factor this. So it's going to be x plus 8 squared. This goes here. This goes here. 63 minus 64 gives me negative 1. So that is the vertex form. F of x equals. The vertex is going to be negative 8, negative 1. While the axis of symmetry is just going to be x equals negative 8. So now they want us to factor it. Okay, to factor it, remember, take factors of 63, that will add to give me 16. Because the last number is positive and the middle number is positive, they're all going to be positive. Remember, I told you, if you don't have to list all the factors, if you can just find the factors. So that's what I'm going to do here. Well, I know 9 times 7 gives me 63, and 9 plus 7 gives me 16. So my factored form is going to be x plus 9 and x plus 7. Roots are the same thing as solutions. Set them equal to 0. Sorry, that should be a 7. So that my answer is negative 9 and negative 7. Okay, so for problem number 23, instead of giving you the standard form, they give you the vertex form, and they want you to go to standard. If you notice, to get from vertex to standard, all you're going to do is do x minus a half times x minus a half, because all of this is being squared, so it's that times itself, minus 25 over 4. Use the full method. We've talked about the full method before. X times x is x squared. X times a negative 1/2 is negative 1/2 x. Negative 1/2 times x is negative 1/2 x. And negative 1/2 times negative 1/2 is a positive 1/4. Now, when you add, well, not really add, it's negative 1/2 minus 1/2. Leave x squared. Negative 1/2 minus 1/2 is really negative 2 over 2, which becomes negative x plus 1/4 minus 25 over 4. Combine like terms, you get x squared minus x minus 24 over 4 which will then reduce to minus 4. I'm sorry, not minus 4. I wrote that wrong. It's 4 here, and it'll be minus 6 there. I just wrote it wrong, and that's my bad. Okay. The easiest way to factor this is using the standard form. So I'm going to rewrite x squared minus x minus 6. Factors of negative 6. 1, 6, 2, and 3. Because negative 6 is negative, and the middle sign is negative, the bigger number is negative. These two will add to give me negative 1. So it's going to be x plus 2, x minus 3. Set them equal to 0. Subtract 2 from both sides. X equals negative 2. Add 3 to both sides. X equals 3. So that my final answer is negative 2 and 3. Topic 4, solving quadratics by square roots. When you're solving quadratics by square roots, you are trying to get the x squared by itself. For this problem, the first thing I have to do, add 1 to both sides. So I get 16x squared equals 1. Divide both sides by 16. So that I get x squared equals 1 over 16. The inverse of something being squared is the square root symbol. Square root both sides. So that I get x equals the square root of 1 over 16. This is not your final answer. It can simplify. So simplify it to x equals the square root of 1 divided by the square root of 16. The square root of 1 is 1. The square root of 16 is 4. Do not forget your plus or minus in front. That is your final answer. 25. Subtract 11 from both sides. Divide by negative 3. So that I get x squared equals negative 2. Do not forget your complex rules. When I square root both sides, I get x is equal to negative square root of negative 2. Split it up. Remember, the square root of negative 1 is going to be I. The square root of 2 is already in its simplest form. So leave it as the square root of 2. 26 is a little bit different, okay? Just a little bit different. Because we have two numbers being squared, this is how I would solve 26. First, I still want to isolate the square, and 26 is already isolated. Go ahead and take the square root of both sides so that my square root and square cancel out. I'm left with x plus 5 equals the square root of 4 is plus or minus 4. Don't forget both signs. From here, split it up so that x plus 5 equals positive 4 and x plus 5 equals negative 4. Subtract 5 from both sides. X equals negative 1. Subtract 5 from both sides. X equals negative 9. Same thing. Get this by itself. To get that by itself, add 7 to both sides. So that you get x minus 8 squared equals 32. Square root both sides. X minus 8 equals the square root of 32. Now, 32 is not a perfect square. So this is how you would write this one. Go ahead and break this down. A perfect square that will go into 32 is 16. So that you get x minus 8 equals plus or minus 4 square root of 2. I still have to get 8 by itself. So you can write it like this. Add 8 to both sides, and you get x equals plus or minus 4 square root of 2 plus 8. I am okay with you writing the answer out like that. That is okay. So this would be your final answer for 27. Okay, so skip topic. I believe this is going to be the end of the study guide because we haven't covered any of this yet. So if you have any questions over the study guide, please let me know. Okay, I will do my best to help you out. And don't forget to study for your test.